Hello everyone, this is Dr. Raviraj Kulkarni. In this video, I'm going to share some tips and solve some CET questions on chemical kinetics. This video will help our PUC students to prepare for CET exam. In CET, time management is very important, so one has to be very quick. I thought I should help the students by giving some tricks and tips. Okay, let's go to the first slide. Chemical kinetics. What is chemical kinetics? Chemical kinetics is the branch of physical chemistry that deals with the rates of chemical reactions. It also deals with order and molecularity of reactions, factors influencing reaction rates like temperature, initial concentration, pH, etc. And more importantly, here we will solve some problems on chemical kinetics. Our interest is to solve problems, and I should give some tips to solve problems. First, we should list out the important formulae and units. The first one, for a chemical reaction, N molecules of A reacting with M molecules of B, giving P molecules of C and Q molecules of D. Here the molecularity of A is N, molecularity is N. So when we write the rate is A is disappearing here, so it is minus dA by dt. So you have to divide that molecularity 1 by N into dA by dt. This negative sign here indicates A is disappearing, A is reacting. Similarly, you can write it for B. It is minus 1 by M dB by dt. So it's also disappearing, it is reacting. If you want to write in terms of C, which is appearing, which is forming, so it is 1 plus 1 by P dC by dt. Similarly, you can write for D also. Right. For a general chemical reaction, A molecules of A plus B molecules of B giving products, rate is equal to dx by dt. That is equal to K into concentration of A raised to M into B raised to N, where M and N are orders with respect to A and B respectively. Overall order of the reaction is M plus N. For a first order reaction, A giving B, rate is given by, so A is disappearing, so minus dA by dt. So that is equal to K into concentration of A. Right, for first order reaction, rate constant is given by K is equal to 2.303 over T into log to the base 10 of A by A minus X. This is very important formula. Some more important formula and units. Fourth, unit of rate constant, general right unit, we write mole raised to 1 minus N, liter raised to N minus 1, time raised to minus 1, where N is the order of the reaction. Unit of zero order reaction, rate constant. Unit of rate constant for zero order reaction, you just substitute N is equal to what? 0. For zero order reaction, it is N is equal to 0. So mole raised to 1 minus 0 here in this equation, mole raised to 1 minus 0 is mole, liter raised to 0 minus 1 per liter per time. So what is the unit? Mole per liter per time is the unit of rate constant for zero order reaction. Similarly, for first order reaction, you substitute N is equal to 1 there. So in this equation, mole raised to 1 minus 1, liter raised to 1 minus 1 per time. So what is left here? Per time. It may be first order reaction, rate constant, unit is per time or per second or per minute, whatever it is. So unit of second order rate constant, you substitute 2 here, you get liter per mole per second or per minute per time. So next we'll go to equation for half-life period. Okay, for zero order reaction, T half is equal to what? A naught by 2K. So zero order reaction, the T half depends on the initial concentration A naught. For a first order reaction, T half is equal to 0.693 by K. T half is 0.693 by K. So it is independent of initial concentration of reactant. For an nth order reaction, T half is proportional to 1 by A naught raised to n minus 1 for all n is greater than or equal to 2. Okay. So these are the important formula and units you should remember before we solve any numerical on this. Let's start with the first question which has appeared in your earlier question paper. The plot of T half versus R naught for a reaction is a straight line parallel to x-axis. The unit for the rate constant of this reaction is option A, mole per liter per second, option B, mole per liter per second, option C, liter per mole per second, option D, per second. So what they are given, T half is independent of initial concentration. That's what they are telling. Okay, when you plot a graph of T half versus R naught, so it's a parallel straight line parallel to x-axis. Okay, so T half for zero order reaction, we know it depends on initial concentration. We know for first order reaction it is independent. So here it is independent. For second order reaction also it is dependent on R naught. So what is the answer? It is first order reaction. So unit is per second. So option D is correct. Next question, question number 2. 1 liter of 2 molar acetic acid is mixed with 1 liter of 2 molar ethanol to form an ester. The rate of the reaction with respect to the initial rate when each solution is diluted with an equal volume of water will be A 0.25 times, B 2 times, C 0.5 times, D 4 times. I have already given the answer here. It is 0.25 times. Why? Let's start. Okay, let's see what is the solution for this. Acetic acid reacting with ethanol forming ethyl acetate plus water. So initial rate of the reaction before dilution, what is rate of reaction? The rate is equal to K into concentration of acetic acid into ethanol. Right. After dilution, what happens? See, if you take 2 molar solution, 1 liter of 2 molar solution, you add another liter of distilled water into it. What happens to the concentration? It becomes 1 molar. It becomes half. So concentration of acetic acid and ethanol become half when each solution is diluted with equal volume of water. So rate 1 I'll take here, I'll write here. So that's equal to K into acetic acid concentration divided by 2 and ethanol concentration divided by 2. K into acetic acid concentration into ethanol concentration, what is that? It is the rate. So rate divided by 4, that is 0.25 times. The answer is A, 0.25 times. Next question. For a reaction 2SO2 plus O2 giving 2SO3, the rate of disappearance of O2 is 2 into 10 raised to minus 4 mole per liter per second. The rate of appearance of SO3 is, they are given 4 options. We'll see which option is correct. Solution: for a reaction, for the reaction 2SO2 plus half O2 giving 2SO3, rate is given by what? Rate is equal to minus dO2 by dt. Okay, what is the molecularity of oxygen? It is 1. So 1 by 1, I have not written 1 by 1 here. Minus sign indicates it disappears. Okay, minus dO2 by dt is equal to SO2. This also disappears, right? That is minus 1 by 2. Molecularity is 2, so it is minus 1 by 2 dSO2 by dt. That is equal to plus 1 by 2. So 2SO3 is forming here. So plus 1 by 2 dSO3 by dt. So minus dO2 by dt is equal to what? So ignore this term. Okay, just they want the relationship here, right? They have given only oxygen, right? Disappearance rate. So dO2 by dt is equal to plus 1 by 2 dSO3 by dt. Next. So plus 1 by 2 dSO3 by dt is equal to what? 2 into 10 raised to minus 4, right? Mole per liter per second. So next, so rate of disappearance is 1 by 2, you take this side, so it becomes 4. 4 into 10 raised to minus 4 mole per liter per second. What is the answer? Answer B. Answer B, 4 into 10 raised to minus 4 mole per liter per second. Okay. Next, for the reaction N2 gas plus 3H2 gas giving 2NH3 gas, the equality relationship between minus dH2 by dt and plus dNH3 by dt is, so I have already highlighted the first answer is correct. So we'll see how it is. So solution, rate of a reaction can be expressed in terms of rate of disappearance of N2 or H2, okay, in terms of or rate of reaction can be expressed in terms of formation of NH3. So rate is equal to minus 1 by 3 d H2 by dt. Why 1 by 3? Because the molecularity is 3 here. So minus sign indicates it disappears. Plus sign indicates here, this side it is ammonia is forming. So it is, its molecularity is 2 molecules of ammonia is forming, right? Right. So 1 plus 1 by 2 dNH3 by dt. Next, minus dH2 by dt is equal to 3 by 2 plus 3 by 2 dNH3 by dt. This is the relationship. Okay. This is a relationship. So answer A is correct. Similarly, one more question was asked in 2070, I guess, CET exam. For a reaction 1 by 2 A, half molecule of A giving 2 molecules of B, rate of disappearance of A is related to the rate of appearance of B by the expression. How it is related? So you can easily solve this. We have already solved 1 or 2 numericals on this. Solution, the reaction rate can be written as A giving 4B. Instead of half A giving 2B, instead of this I can write multiplied by 2. So A giving 4B. So rate of reaction can be expressed in terms of disappearance of A, and rate of reaction can also be expressed in terms of formation of B. So how we can write? So minus dA by dt. So molecularity is 1 here. So dA minus means A is disappearing, minus dA by dt is equal to plus B is forming plus 1 by 4, molecularity is 4, so 1 by 4 dB by dt. Answer is B. This is correct. So plus sign is not there, anyway you can write plus. Okay. Next question. The half-life period of a first order reaction is 60 minutes. What percentage will be left over after 240 minutes? A very interesting question. Option A is 4.25%, option B is 6%, option C is 6.25%, option D is 5%. So we know equation for rate constant, first order rate constant. K is equal to what? 2.303 OT into log of A by A minus X to the base 10. So this is the first order rate constant equation. So how at half life period X is equal to A by 2. So you can write it. So you get this equation. Similarly, you can write the rate constant equation for 240 minutes. That will be this. Okay, equate this with the half life period. So you get 6.25. So one thing you can observe here, it will take at least 2 to 3 minutes or 4 minutes. So you cannot do this kind of stuff in the CET exam. So you cannot solve like this. Okay, you have to find a easy way. So I found a easy way. So the same numerical, my method. Okay, half-life period for first order reaction is 60 minutes. The number of half-lives is how much? 240 divided by 60, that is 4. This means n is equal to 4. Okay, the amount which is left after 4 half-lives is A minus X. So there you just remember this equation. A naught initial concentration divided by A minus X is equal to 2 raised to n. So A minus X comes out to be 6.25%. So option C. So I have another method, just logical method. See, initial concentration is 100%. Okay, initial concentration 100%. So it becomes 50% after how many minutes? 60 minutes. So 60 minutes it becomes 50%. So 50% becomes its half, that's 25% in another 60 minutes. So 25 percentage becomes 12.25% after another 60 minutes, that's 180 minutes. Another 60 minutes it becomes 6.25. So 4 half-lives you can write, can easily write. It's a logical, right? Within 1 minute you can do this, either this method or this method. Okay, any one you can choose, you can easily do it. Whereas the earlier method, see this, imagine this, writing all these equations, horrible, right? So this is easiest method, so you can solve it by this method. Okay, take another example. Question number 7. A first order reaction is 75% complete in 60 minutes. Find the half-life period of the reaction. Answer A 15 minutes, B 30 minutes, C 45 minutes, D 40 minutes. Okay, method 1, see this you have to take the initial, right, rate constant is equal to 2.03 over T into log of A by A minus X to the base 10. Okay, so can you imagine this takes really a long time. Again you get 30 minutes. Substitute this in T half, you get 30 minutes. So it takes more than 2 minutes. So I don't recommend this method. So what do you do? Just remember, apply logic. One half-life period means 50%. Second half-life 50% of 50%, that's 25%. Total 2 half-lives means 75%. 2 half-life means 75%. So what do you have to do? 2 half-lives means 60 minutes. 1 half-life means 30 minutes. Just within 30 seconds you can solve this. Apply logic. There is nothing else. If you solve by this method, can you imagine? You won't be able to solve this. Okay, so you got only 1 minute. So this is the tip. So temperature, another question. Temperature coefficient of a reaction is 2 when temperature is increased from 30 degrees Celsius to 90 degrees Celsius. Rate of reaction increases by 150 times, 240 times, 72 times, 64 times. So what is the solution? So temperature coefficient means what? K, right, T plus 10 divided by KT. So every 10 degree rise, what is the change, right, whether the reaction doubles or triples or whatever it is. So 2 it is, reaction coefficient is temperature coefficient is 2, means reaction doubles. So temperature is increased from 30 degrees to 90 degrees Celsius. So that is total 60 degree change in temperature is 60 degrees Celsius. So rate of reaction is increased by how many times? 2 raised to 6 times. How? Just see, 64 times temperature change rate. Okay, if you increase 30 to 40 degrees Celsius, it becomes double. Okay, 2 times. Another 40 to 50, another 2 times. 50 to 60, another 2 times, doubles. Again doubles. 60 to 70, 70 to 80, again doubles. Right, 80 to 90, again it doubles. How many times it doubles? 6 times. So 2 raised to 6, that is 64. You remember this, right? 2 raised to 6 times. Okay, if it is temperature is from 30 to 100 degrees Celsius, so it is 2 raised to 7. Okay, 128 times. It's like that. If it is 30 to 80 degrees Celsius, 2 raised to 5, that is 32 times. Okay, so here it is 60 degree rise, so the answer is D, 64 times. Next question. A first order reaction is 50% completed in 1.26 into 10 raised to 14 seconds. How much time would it take for 100% completion? You remember, the reaction never becomes 100%, because what is initial concentration? Concentration A is equal to, at any time t is equal to what? Initial concentration, that is e to the power minus rate constant into time. Okay, so concentration of A versus time, if you plot, it never reaches 0. So there will be some reactant left, so it won't reach 0 because it's an exponential quantity. So it takes infinite time. Answer is infinite. You can solve this, but anyway you get infinite. So please like, share and subscribe if you have not done so. If you have any doubts and queries, if you want me to make more videos, then please write to me. My email ID is dr_Kulkarni_1976@yahoo.com, or you can just comment to this video in YouTube as well. Thank you for watching. All the best.